Okay, today we are going to learn 3 strategies for factoring. These are I don't want to call them cheats. Let's call them hacks. They are quick ways to factor that do not require you to actually stick it in a box or to, I'm sorry, I'm going to adjust the focus here. They don't require you to stick it in a box or do the Big Texas method. You just look and figure out what the answer is, okay? So I'm going to teach you 3 strategies. The first one is called eyeballing it, because all we're going to use to factor is our eyeballs. We're going to look at it and find the factors of these expressions. Now, eyeballing it works when A equals 1. As you become more fluent at factoring, you may be able to do this with things where A isn't 1. But you notice, again, every single one of these problems I have here have an invisible 1 in front of the squared variable, so their A is 1. Okay? So, the way that this strategy works is literally all you do is, you know how like when we did our factoring before, we did the Big Texas and we had all this stuff. Oh, okay, I'm flipping my notes the wrong way. But we did Big Texas and we had all of this stuff written down, okay? And like that's a lot. It's not a lot, but that's neither here nor there. So what we do this time is all we use is the X, and eventually, again, as I said, as you become more fluent, you won't even need to use that. So we're going to use the X part. If you want to do the big T, you can. Okay. So remember, when we do the big X, A times C goes up here, and B goes down here. So let me just write that real quick. And y'all don't have to write it, but I'm just using it to show you. Let me just focus again. I'm so sorry. That didn't really even help. Oh, there, that's good. So with this, A times C is 8. Right? Because 8 times 1 is 8, and B is 6. So all I'm doing is I'm thinking about the factors of 8. Well, I can do 1 times 8, that's going to add up to 9. 2 times 4, that's going to add up to positive 6. So literally, I write X, this is positive 2 and positive 4 plus 2 plus 4. And that is our answer. That is how you use the eyeballing it strategy. Okay, let me do that again so that those of you who need to see it can see it. Let's look at this one over here. All right, so again, I'm going to make my X. If you need it, you may not. 10 times 1 is 10. So really all I'm putting over here is C. Okay, and the 7 goes down here. Okay, well, what factors are there of 10? Well, there's 1 times 10, which that adds up to 11, so that's not it. There's 2 times 5. Ooh, 2 times 5? That adds up to 7. Positive 2 and positive 5. So I'm going to put an X in the front. Plus 2 goes after it on one of them. Plus 5 goes after it on the other. This only works for you right now at your level of fluency when A is 1. Okay? So let's take a look at this one. I want you to just think for a second about what's different about this one. Well, what I can see immediately that's different is this has a plus and that's got a minus. The strategy still works though. So if I make my big X, I need to put C up here at the top, or A times C, and negative 7 at the bottom. So now I'm thinking about my negative factors because I need them to add up to negative 7. So 12 times 1, 12 plus 1 adds up to 13. That's not it. What's next? 2 times 6, 2 plus 6 adds up to 8. That's not it. 3 times 4, 3 plus 4 adds up to 7. But I don't want positive 7, I want negative 7. So I need to use my negative factors. Negative 3 times 4 multiplies to 12. Negative 3 plus negative 4 gives me negative 7. So now when I write my parentheses, I'm going to say X, minus 3, X minus 4. Does it matter that I almost wrote X minus 4 first? No. Okay. This last one is the only one that's a little bit different from what we've been doing. Okay. So I still put my negative 15 on the top. I put my negative 2 on the bottom. Now this time, since this is negative, I'm looking for a difference. So I'm looking for when this sign is negative, I'm looking for a difference. So 15. So 15 times 1 is 15. That's going to add up to 14. 2 doesn't go in. 3 times 5. 3 times 5 is 15. 3 times, okay, so 3 and 5 I can get 2 out of. So let's look at that. If I put those down. I need the 2 to be negative. So I need the 5 to be the negative 1 because I need to end up with more negatives. So I do X plus 3 x minus 5. This is it. This is how you eyeball. This is the eyeballing strategy, okay? And again, if you don't feel comfortable doing this, then keep on putting it in the fact, keep on doing big Texas, all right? That's fine. But this is a quick method to factor. And you can always check with the calculator. I can put this in the first row and that in the second row in the calculator in Desmos and see if they match. If they do, yay, go me. It worked. If they don't, well, you know, I got to try again. Okay. Now, second special pattern. Now, these are special patterns, and these special patterns are on your formula chart, and we put them right here. So these special patterns are on your formula chart. You don't have to memorize them. Now, the thing that's a little weird about them is this A and this B are not the A and B that we've been using. Okay. So they're a little bit different than what we've been doing. So don't stress about it though. Okay. So this is difference of two squares. Dots, we call it dots. And when you see this pattern, your work is literally the word dots. That's it, okay? So what am I looking for? Well, first of all, it's the difference of two squares. So I should only see two terms in this expression. And I see 1, 2, 1, 2, 1, 2, 1, 2, okay? They're not a different, and then it has to be subtraction, okay? So I'm looking for two terms that are being subtracted. And some of you are already probably thinking about something right now, and that's okay. All right. So then what I'm going to do, once I see that I have two terms, I look for perfect squares. X squared is x times x, so I could literally write x times x. Let me zoom in a little bit. And 25 is 5 times 5. Those are perfect squares. So now that those three conditions have been met, now I can actually fast factor them. Okay, again, using this pattern. So the pattern says a squared minus b squared equals a plus b, a minus b. So I can tell already that since I've got those two, the a squared minus b squared, so this would be my a squared minus b squared. So if I wrote it above there, I need just a in the front. So how do I find a? Well, if x squared is a squared, then to find a, I have to take the square root. Well, the square root of x squared is x. So I put an x, and then a is in the front of each of those. Okay? One of them has a plus and the other one has a minus. And then the last thing says b squared. Well, if I want, and I have a b at the end. So if I want the b, I have to take the square root of 25, which is 5. Okay? So what this pattern is telling me is, if I take the square root of the first term and put it in the front, the square root of the last term and put it in the back, put a plus and a minus in between them, it's factored. This is done. If I were to put these in my calculator, I would see the exact same expression. If I were to graph this and graph that, they are equivalent. So I can put them in the calculator, check right away, and that's the pattern. Okay. Let's take a look at this next one. Okay. So again, I have two terms. 9x squared, 3 times 3. X times x. 16 is 4 times 4. These are perfect squares. Is it subtraction? No. So this is actually also a special pattern, and this is actually prime. Really? This is actually prime. It's not factorable. Okay? Hold on one second. I'm going to pause this video just briefly. Sorry about that. I actually ended up stopping the video, so now I've got to stitch them together, but that's okay. So this one is actually prime, which means it's not factorable. So the difference of two squares, I can use fast factoring on. I can kind of fast factor the sum of two squares too, because it can't be factored. So if instead of a difference you see a sum, you can't factor that. It is not factorable. All right? So now, let's get back to this one. Okay. This doesn't look like a difference of two squares to me. Okay, because 75 is not a perfect square, and neither is 12. But it is two terms, and they are separated by a subtraction sign. So, like, you know, my math senses are tingling. What is the first step always of factoring? The first step of factoring is to find a greatest common factor. Okay, 75. I'm not going to belabor the divisibility rules, but 75 can be divided by 3. And so can 12. 75 divided by 3 is 25. 12 divided by 3 is 4. Well, now is this a difference of two squares? Absolutely. What do you think I'm going to do very, very first? if you know me very well at all, I'm going to write a 3 with 2 parentheses next to it. And I'm just going to go ahead and put a plus in one and a minus in the other. Why am I going to put that 3 there? Because if I don't do it right this second, I'm going to forget about it. I'm not going to come back to it later. Okay? So now 25 is a perfect square. It's 5 times 5. 4x squared is a perfect square because 4 is 2 times 2. And x squared is x times x. So I'm literally just going to take the square root of the first term. Square root of 25 is 5. That goes in the front. The square root of 4 is 2. The square root of x squared is x. The 2 x's go in the back. Plus and minus separates them. Okay? Last one. Again, I look at this. 4 looks like a perfect square, but I don't know. I mean, is 484 a perfect square? Second quit. 484 divide, square root of 484. Yeah, it is a perfect square. However, I still got to look for a greatest common factor, because if I don't look for the greatest common factor, so technically, I'll just tell you right now, I could get the answer 2x plus, that was 22, 2x minus 22. But that is not fully factored. So if they're asking me for a fully factored answer, that is factored, but it's not fully factored. And there's a lot of different ways that that greatest common factor could work out. I could get like 4x plus 44 times x minus 11. There's lots of different ways that that greatest common factor could come into play. So we have to get rid of the GCF because it changes what my factors look like. It makes it not fully factored. Okay. When I do that, I get x squared minus 121. Well, I know my perfect squares. So I know that x squared and negative 1 and 121 are perfect squares. But if you don't, and I know this isn't the calculator would use, you would just type SQRT 121 in your Desmos calculator, and it'll tell you that's a perfect square. If you're not sure, put it in the calculator. Okay? So again, I'm going to write 4 in my parentheses. The square root of x squared is x, that goes in the front, plus in one, minus in the other. Square root of 121 is 11, and now it's fully factored. Again, this is factored, but it's not what I want. I want a fully factored answer. This is a more correct answer. Might you see this? Sure, but this is the fully factored answer, okay? Last special pattern I'm going to teach you is perfect square trinomials. This is the one y'all like the least. Unfortunately, this is the one I need you to understand the best because we're going to be doing a strategy called completing the square. So first of all, okay, we're going to change this a little bit right here. Does B equal, I don't like this. Okay, so is the middle term, does the middle term equal 2AB? Okay, because I want you guys to use this pattern. It's on your formula chart, why not? Okay, so here's some rules of perfect square trinomials. All right, first of all, there have to be 3 terms. It's a trinomial, it's got to have 3 terms. All of these have 3 terms, okay? Second, are the ax squared and c terms, so the first and last term, so the quadratic and constant, have to be positive perfect squares. So if this was a minus sign, I would immediately eliminate it. This cannot be, the last term cannot be negative. And you can see it right here. It has to be positive. Okay? So the last term here has to be positive. Okay? If it's not, we're not looking at a special factoring situation. Okay? So I'm going to treat this, so this is a trinomial, but I kind of do the first steps just like the other one, okay? I make myself 2 sets of parentheses, okay? Now, the last thing is a little tricky. So I'm going to do this first part right now. I'm going to expand it with x times x here, and this is 3 times 3, okay? Now, it says, in this right here, it says the middle term should be 2ab, and it's calling this a squared plus 2ab plus b squared, right? So what I should see here is 2 times a times b, okay? Well, to find a, I take the square root, which is x. So 2 times x times the square root of the last term is 3. 2 times 3 is 6x. Do these two match? Yes, I have a perfect square trinomial. So the strategy is this. Okay, really quick, let's pause for a second, and I want to do that again on this one here. Okay, so again, I look. Do I have a perfect square in the front? I do. Do I have a perfect square in the back? I do. Okay, is this term positive? Yes, it is. Okay, this should be 2 times x times 10. Is it 2 times x times 10? No, that would be 20x. This is not a PST. In fact, I don't think it's factorable. But that's neither here nor there. It might be factorable, I'm not sure. Okay, this is not a PST. So this is not what we're looking for. Look at this one down here. Okay, so again, I'm going to expand it. 2 times x times x. 1 times 1. Yes, 1 is a perfect square. Okay, so I have a positive third term. That was what was wrong on that one. Okay, this one, I'm going to take this. This should be 2 times 2x times 1. That's 4x. Is that what I've got there? Yeah, so this is a perfect square trinomial. So I can use this fast factoring pattern. Okay, so do you kind of see what we're doing there? Hopefully. If not, I'll be here tomorrow for questions. All right, now this. So what you do is exactly the same thing, almost exactly the same thing as you do with dots. I start with the square root of the first term in the front. I put the square root of the last term in the back. But the thing that's different is, with a trinomial, I use the same sign. Whatever's in front of my middle term, that's what sign goes between them. And the reason I call it a perfect square trinomial, because I can rewrite that expression as a perfect square. Okay, so what would I write this one as? I want you to just take a second, try it. I'm not going to make you fill in an answer, just take a second and try it. Okay, so what I would put is, well, first of all, I see that this is a plus, so I'm going to put a plus inside each of them because they are both pluses, and you can see that here. When this term is positive, I put a plus in the middle. When this term is negative, I put a minus in the middle. Okay, so I'm going to take the square root of the first term, 2x, and that goes in the front. I'm going to take the square root of the last term, 1, and that goes in the back. Perfect square trinomial because I can write it as a perfect square. Okay, this one here is kind of a mess. This one's a lot. Okay, so let's look at it. Okay, I'm going to do the same exact thinking as I do. It's got 3 terms. Go me. 4 is 2 times 2 times x times x. This is a perfect square because I could take the square root of it. This is 3 times y times y. Also a perfect square. A little crazy looking. Okay, so I want to see if the middle term is 2 times the square root of these terms. Okay, well 2 times x times 3 times y. Oh my gosh, okay, 2 times 2 is 4, 4 times 3 is 12, x, y. Okay, it matches. So this must be a perfect square trinomial. So I'm going to draw my parentheses. Now this time, what's going to go in the middle of them? Well, since this term, I'm sorry, this term is positive, by the way, and this term is negative, when I look at my pattern, which is on my formula chart, if this is negative, then I put a minus sign in the middle. So I'm going to put a minus in the middle instead this time. Okay? And then I take the square root of the first term, 2x, and it goes in the front. I take the square root of the last term, 3y, and it goes in the back. It's a perfect square trinomial because I can write it as a perfect square. All right. Whatever questions you have, please think about them now before you just go none, because I know y'all got questions. And then answer the next question honestly with what things I need to clarify. We will go over these tomorrow in class.